Hi, everybody, and welcome back. So this is our last set of videos for the semester, or at least the last set of the planned videos. We may add some more supplemental stuff, but for now, this is basically we're wrapping up. We are going to be putting a nice bow on top of everything that we've covered. So far, we have learned this semester how to write reproducible scientific reports with Quarto. We've learned how to make beautiful graphs with ggplot. We've learned about how R thinks about vectors, both atomic and non-atomic vectors, and also rectangular data. We've learned about importing and wrangling your data with the readr, the Tibble, and the dplyr packages. We didn't cover a whole lot of stuff out of the Tibble packages, but we definitely covered a lot about what Tibbles are and how we can interact with them. We talked about working with strings with stringr, and then we also learned a lot about functions, functionals, control flow, and how we can apply these functions with the per package. So at this point in the semester, we've got a whole bunch of tools in our toolbox, and it's time for us to start bringing them all together and working on one really cool project. Okay, so the final project for this class, which is not it's not posted online. It's not one of the materials that you can have online. Will be to take a whole bunch of data sets from either from the CDC or from the Department of Health and Human Services or the NIH or something, and wrangle all of those data sets together. I mean, hundreds of data sets, wrangle them all together and summarize the data and write a report with Quarto that includes figures with ggplot. And that's basically hitting all of the major points that we've learned this semester into one giant workflow, one data analysis pipeline from getting the raw data all the way to writing the final report at the end. And that's going to be the final project for the class. Now, I have some ideas on what data sets that we're going to use, but for now, I'm going to give some examples related to the food stamp data that we had talked about in some of the previous videos. So we had talked about the SNAP data, or Supplemental Nutrition Assistance Program data, and the 5-year estimates for that. And you should have this data on your computer. You should have the raw data here. If you don't, just go grab it from the GitHub repository for this class. But you should have especially at least 2 files. One is the column metadata as a CSV file, and the other one as the actual CSV data set. So now that you have them, you already know how to import data. So go ahead and import those data sets into R. And let's take a look at those data sets. So here's my path to the data right here. So I've got I'm storing it in the data directory, and then there's a subdirectory that's for the ACS data, and then I have the actual data CSV. Now here's what I want to do though. Because there are 2 rows of metadata in these files, we need to do 2 different imports. And one import will just give us the column names, and that's this bit right here. So we're going to read in the column names as the CSV here, but only with 0 rows, because there's no reason to import the data if the only thing that we need is the column names. So we're going to take the column names from this 0-row Tibble and store this as a vector, and then read the data again, but this time skipping the first 2 rows because there's 2 rows of metadata, adding in manually the column names that we imported up above, and then this will be the data set. So there's going to be so up here, whenever we were just grabbing the column names, there were 0 rows, 459 columns. Now there's going to be 1,013 rows, the same 459 columns. But here, notice that we've already specified the column names here. The metadata, like the information about the column names, we don't need to do these tricks. We can just import it directly as is. But the data sets, the actual data files themselves, they had 2 rows of metadata information, 2 rows of column headers. I have seen some data sets from the CDC that had upwards of 4 or 5 rows of column information. And so the data, you would have to set the skip to be like 5 or something. And you do one import that just gets the column information out that you need. And then the next import, you would skip those first 5 rows and just import the data from there. So be aware of that a lot of times, especially with CDC data, you'll have to skip a couple of, you'll have to do 2 separate imports. One is for the column names, and then the next import, you would skip through the first couple of lines of meta information and then just pull the data. So here's the metadata. It's 458 rows, which should match our 458 columns or thereabouts. And there's only going to be 2 columns here, and these columns are I'll skip forward. The metadata, this is the column abbreviation, like our special secret code number or whatever. And then this is what it actually means. Like this is like just a whole bunch of description of what's going on in that column. This is what the data set itself looks like. So here's our column names here. But notice that this is kind of difficult to work with. Like we don't have all of these things memorized. So that's why we need the metadata information to deal with this. Okay, so yeah, so you can see here that this thing right here, this name, this is the geographic area name. That's going to be our zip code. Is a ZCTA, which is zip code tabulation area. It's not exactly a zip code, but it's close, and it's what the CDC uses. So here's what I want you to do. I want you to make sure you get with your partners or with your team. And as you know, in your team, you should have somebody that's you've got your biostat or data science expertise, and then also someone with the domain knowledge. So make sure that you're not all epi students in one team, or all biostat students in one team, or all population health in one team. So all of you are coming from the different disciplines within public health. And so you should kind of cross-pollinate and make sure that you're working with people who don't come from your department, so you can learn from them and they can learn from you. So get into your diverse teams and figure out what kind of questions you would want to ask about this data. And you have access right here to the metadata. Go through this metadata and start looking at, of the 458 things that are measured, what are some things that you would be interested in learning about? Okay, now we've got almost 460 columns to go through, so we're definitely going to need a better summary function than just the base summary function. And if you remember, we had actually written a decent one. I mean, it's still a little bit frustrating that we're having to use the table function, but it's okay for now. It's probably not worth our time to try to make that a whole bunch better. But here it is. We've got our summary function. And we know how to write this. It's missing documentation. As one of your assignments, you were supposed to have, I think this is a couple lessons ago, you were supposed to have written documentation for this function. So just make sure there's documentation for your function. And now let's apply it to the raw data. But here's what I want to do though. I don't like if we've got 460 columns, there's no way I can go through all 460 columns, at least not in class. Now, whenever you get to your project, like the actual project that you turn in, not the material that we're doing today, but the actual project, you and your group, you should break this up and actually go through all of the hundreds of columns that you have to deal with, and make sure you understand what's in that data. But for just an example right now, we're actually going to take a sample of the columns. So I already know that the column 1 and column 2, we don't need to inspect. So I'm going to sample between 3 and 468, and I'm going to take a sample of size 50. So I'm going to get 50 random columns, other than the first 2, because those are kind of simple. And I'm going to try to figure out, well, what are these columns that we care about? So these are the random columns. There's going to be 50 of them for us to kind of wrap our heads around what's going on in the data. So what we're going to do is we're going to take our tibble here, and we're going to select the random columns, the 50 random columns, and then apply, so the map function, apply our summary function to the 50 random columns, and then just take a look at what we've got. So we've got numeric information, a lot of numeric information. This is totally fine. But then we've got something like this. Okay, so this was character information. Now, why is this character information? We've got actual, what appears to be numeric values. Man, that sneeze snuck up on me. I'm so sorry about that. So we've got numeric information, but this is coming through as character information. And it's because we've got this crazy symbol here, right here. And then here's another one. We've got another crazy symbol here, right here. We've got another crazy symbol right here. So we're gonna get down here, and this is my exercise for you. I want you to go through. You see a bunch of these crazy symbols here. Find out what these symbols mean. Okay. So that means that you're going to have to look in the documentation file. You're going to need to find out what they mean. And you're going to need to add comments in your code to define what these symbols mean and how they should be, because they're clearly representing some kind of missing data, but we just don't know what. Okay. So some kind of missing data, like we need to mark maybe different than others, but you need to figure that out. So you're going to have to go into the documentation and find out what's going on in this data and replace them with NA values as appropriate. All right. And that'll be the end of this part, and we'll pick back up with a review of string functions next time. All right. See you soon.